So looking at that diagram, where is the electric field the strongest?
Meet Dr. Patrick Motl. He teaches physics, hosts a monthly community outing at the observatory, volunteers time at a summer science camp designed to reach out to underrepresented groups of future scientists, and to top it off, Dr. Motl is a recent recipient of a NASA grant worth up to $350,000. Talk about astronomical. I'm Shane Simmons, and I'm an intern for the Office of Media and Marketing here at Indiana University Kokomo. Follow along as I talk with Dr. Motl about the grant and how he is making IU Kokomo his campus. Hey, Dr. Motl.
Hi.
I heard you recently received a grant from NASA.
I did. It was a very pleasant surprise.
Will you tell us about the grant?
It's a very competitive process, so we put together a proposal where we outlined what research we would do over the next 3 years to help support NASA space missions that are looking at these sorts of bursts of gamma rays. And we were trying to study what sort of emissions you would see when a neutron star merges with a black hole.
Okay, wait. What's a neutron star?
A neutron star is like taking an entire sun worth of mass but squishing it down to a size smaller than Kokomo. About once per day you see a burst that lasts like just a second of very high energy light, and those are these gamma ray bursts.
Gamma ray burst. Think about it this way. You have two semis traveling at the speed of light, and they have a head-on collision with one another. Big explosion.
And we think that some of those gamma ray bursts are caused by the merger of two dense stellar remnants. Perhaps one is so dense that it's even collapsed all the way down to make a black hole already.
So you might be curious what this all looks like. How about an animation, Dr. Motl?
So this is from one of our simulations from a few years back, and so this is showing a black hole and a neutron star, and they'll be together in an orbit. And so that solid circle is showing what's called the event horizon for that black hole. That's the last surface where you could have any interaction with the outside world. To get away from there, you'd actually have to travel at the speed of light. So as the neutron star gets in closer and closer, the tidal gravity from the black hole is shredding it apart, and then material is going to fall back in.
Hey, Dr. Motl, I'm not seeing anything. Can you tell me why I'm not seeing this through a telescope?
These are all so far away, and the black hole and the neutron star in terms of physical size are so small, you'd never be able to resolve this. You just see a burst of light or other signatures from it, and you want to try to connect what things you can observe with what we think happens theoretically, and numerical simulations can help us do that.
So this all sounds pretty cool, but I had to ask, will students be able to help?
Yes, we'll have support in the grant for undergraduate researchers at IU Kokomo and at Brigham Young University. So at IU Kokomo, we'll have students hopefully help out with some of our analysis and visualization from our simulations, and also help shepherd through some of the runs.